Alright, hello everybody, Mr. Wallace here. Today we're going to learn about solutions and concentration, as well as some about molarity. Now, solutions aren't just a part of daily life. They're also very important in industrial processes and also water quality. So let's get started and find out what a solution is. Solution is not just the answer to a problem. In chemistry, it's one substance that's dissolved into a large quantity of another substance. So some vocabulary here. The solute is the substance that is dissolved, and the solvent is the substance that does the dissolving. Let's talk about some examples and identify what the solutes are and what the solvents are. Now we have Kool-Aid. The solute is the actual mix, the sugar and the dyes that get dissolved in the water. The water is the solvent in this case. Next we have milk. In milk, there are many dissolved sugars and lipids, as well as hormones, and those are all dissolved in water. Bleach is another example, the solute being sodium hypochlorite, and the solvent again is water. All of these examples are going to have water as the main solvent because we don't really see examples of solutions that aren't just salt, that don't have water as their solvent. They're more used in the laboratory if they don't involve water. Some things are better dissolved in hexane or ethanol, but those aren't really common day substances we're going to talk about. In seawater, there's lots of metals and salt dissolved in the water, which is the solvent. In coffee, there are many solutes that get dissolved when hot water passes through ground up coffee beans. The solvent does the dissolving, and the solutes are what are dissolved. And in vinegar, which is just acetic acid, your common day vinegar is 5% acetic acid, 95% water. The water being the solvent, the solute, acetic acid. So let's talk about concentration. Concentration is how you talk about how much solute is dissolved in the solvent. So a solution that only has a small amount of solute in it is called a dilute solution. A dilute solution has a very low concentration of the solute and is said to be very weak. And a solution with a large amount of solute is said to be concentrated. The different amount of solutes dissolved in the solvent determine how much of a chemical reaction can take place. Now, molarity is a common tool that scientists use to measure the concentration in solvents, or the concentration of solutes in solutions. Now, you don't usually hear of molarity in everyday terms because it's not really a useful measurement in daily life. We're not conducting chemical reactions and trying to be as precise as possible with that. But with molarity, by knowing the molarity and volume of a solution, you can calculate the moles of solute that's contained in that solution. You will know precisely how much solution you need to make a chemical reaction go to completion. So a good example of this is baking soda and vinegar. You know how much acetic acid is in your vinegar solution, and you want that to react completely with the baking soda. If you use too much vinegar, you're just wasting the vinegar, and that part of the acetic acid is not going to react at all. If you don't use enough vinegar, then there's still baking soda left over that could have made more of a volcanic explosion for a science experiment. So molarity is defined as the moles of solute per liter of solution. It quantifies how many moles there are in a liter of solution. So that's the real important part to take away from this, is how much per volume. That's what we're going to be looking at later when we're doing our calculations calculating molarity. So when a solution process takes place, the hydrogen bonds of the water, also many molecules of water surround the solute, and they break apart the bonds between those different solute molecules. So they break them apart and they dissolve into the solution. And then they become, over time, evenly dispersed throughout the solution. So no part has extra and no part has fewer ions in it. The volume of the solution does not change after the solute is added. So there's been many experiments showing that when you dissolve a solute, it becomes part of the solution without adding any volume. It's so much surrounded by the water molecules or the solvent molecules that it's made compact and does not add any volume. So let's define what a mole is. A mole is a certain amount of molecules or atoms, entities, that exist within a certain mass of substance. So Avogadro's number tells us that there are 6.02 times 10 to the 23rd molecules in 1 mole. So when you add 1 mole of baking soda and 1 mole of acetic acid, you know that there are 6.02 times 10 to the 23rd molecules of each that are going to interact and make a chemical reaction. So this is why we use molarity. Also, volume is defined as a 3D space. A substance that takes up a 3D space is known to have volume, and you can measure this. Now let's just go back and look at the equation, because we are going to be using this in an example in just a minute. Once again, molarity is the moles of solute divided by the liters of solution. So that means the units we're going to use are moles per liter. You need to make sure that you're not using moles per milliliter or grams per liter. We've got to use these specific units in order to find the right calculation of molarity. And there's a lot other measures of concentration that we will get into later, not for this lesson. There's also percent by weight, percent by volume. There's molality, and there's also several different techniques called absorbance that show the concentration of something. So let's get into actually solving these problems. Just a minute and I will transition. Okay. Number 1 says, if I can get to it, 2 moles of glucose is dissolved in 3 liters of water. Find the molarity of the solution. So first we need to write out our equation. Molarity equals moles solute divided by liters of solution. So we know that M is going to be in this case 2 moles of glucose divided by 3 liters of water. We need to make sure we have our significant figures. That leaves us with 0.67 molar glucose solution. So that is how scientists say use molarity in speaking terms. 0.67 molar glucose solution. Next we have example 2. 1.5 moles of potassium is dissolved in half a liter of water. Find the molarity of this solution. So once again, let's write out our equation. This time we can use the symbols. Number of moles over volume. 1.5 moles of potassium divided by half a liter of water. That should give you 3 molar potassium solution. Now the third example is a bit different. Instead, we're given 2 different quantities. We're not just given the moles and the volume. We are given 0.1 liters of 2 molar hydrochloric acid solution. So again, we'll write this out. We need to identify which 2 parts we have and put them in the correct spot. So we know we have 2 molar. We don't know the moles, but we do know the volume. So in order to solve this problem, we need to multiply each side by 0.10. That's how you solve it algebraically. The number of moles equals 0.2 moles of hydrochloric acid. So now we know exactly how much hydrochloric acid is available to react with whatever we want to react to. If we use more volume with the same molarity, we're going to have more moles. Alright everybody, thank you for watching my lecture, and I hope you learned something.